let's learn a little bit more about Gradle specifically. So here we again see the main project structure, and in this example here, you will see that we even included a package here and said, well, you remember, this is the main project structure, source main Java, and test Java, or source test Java. But we can include packages and include more things in there. So this is what Gradle expects. If you need to change that, you can define source sets and say, well, my main Java is just in the source directory, and my test Java, so this part, is just in test. So then this way you can tell Gradle, hey, I have a different project structure. But usually when you keep reading about it and just look up Gradle a little bit, you'll usually see if people say, well, I changed the source set and so forth, many say, well, why don't you just stick to the convention? And I personally agree with that. Stick to what Gradle expects, because then everyone will also know where are your source files, where are your test files, where did you put your resources. I think it just makes it easier and a little clearer. But in case you need it, this is how you can make changes. So we have a couple of built-in tasks that you do not have to specify on your own. Kind of like Maven had, right? You have a couple of things that you can always use. One of them is clean. Clean basically cleans your build directory, so it deletes all your compiled files. So you basically start your compile from scratch. It's called clean, well, and you can call it through Gradle clean. You can call Gradle build, which will basically, well, create a new build and compile all your classes and put them in a build directory. Kind of like the and compile that we had in the other video, where you can basically call it and we create a new classes directory and put all our compiled files in there. In here, it's called build, and it puts all our compiled class files into a build folder. We can call Gradle test, like so. And here we will basically run our test cases, and it'll tell us how many, or if the build is successful, you see that here, and it will tell you if there were some tasks there, and if there are tests included, it will actually tell you if some of the tests failed or if they all passed. They only pass if the build passes when the test pass, unless you specify that you don't want the build to fail for the test to pass. But that's a little bit more complicated than we need for now. We might get to a point where that becomes interesting, but for now it's enough to know, hey, we can run our tests, and when tests are defined, we have tests in that Java test folder, then it'll run our test in our source test Java folder, I'm sorry. And we can call Java run, which will basically use our compiled files from here and run our program. Important, you don't have to call Gradle build before you call Gradle run. Gradle run will also build your software if it's not already built. So here again, we have a simple Gradle file, and just again as a quick overview, we say, hey, we want to use a plugin application for our Java application. We're saying our main class is called main, which will be in source main Java. Then you'll have a main.java file. We're saying, hey, our dependencies, we want to pull them from the JCenter repository. And then here we define two dependencies. Test implementation will use JUnit 412, which will be pulled from this repository. And then for compiling and for running our application, we will use the CLS folder, which is basically, in that case, just a folder which has some compiled classes. I mean, this is, of course, not mandatory. It just shows you that, for instance, if you have some compiled class files that you want to use or that you need to use, you run your application, you can do it this way. Then for tests, you can exclude tests, or you could even include tests. So in that case, I included an exclude and said, well, don't run any tests that are called black box given. And this way, we can say, well, run everything that's in our test folder, but don't run this test. Maybe because of a specific built, these tests will fail, or they're still kind of in progress and they're not done yet, so they shouldn't be run, or for whatever reason. So you can include and exclude tests, which can be very helpful. So you can also create custom tasks, which is interesting because you might have a project where you have different ways of calling something, and in that case, that might be very helpful. So here we have a Gradle task, and our task is called task 1, and we can call it through Gradle task 1. And then we have something you see here, which is called do first and do last. So in a task, you can basically build a stack from the top down or from the bottom up and say, well, first do this. In that case, Gradle even allows us to just print things. So if we call it task 1, it'll print first, and then it'll print last. Second task, task 2, we reverse these. So we're saying, well, do last is first, which is a little confusing, but I did that on purpose, and do first will print last. So thinking about what will happen, well, it should print this first, and then it should print that, right? Because that is a do first that gets put on top, and do last gets put on the bottom. Simple as that. Then we can also define kind of global scope. So these are tasks that are like little tasks, and then you have project tasks. And you define them like this, and you give them a name here. And you can even give them arguments here. And then they can also do things like printing something, or of course doing some more things. And these things will always kind of execute first, or not first, but they will run, right? If you're calling Gradle build, it'll go through this one and this one every time. When you call Gradle task 1, it'll run this. If you call Gradle task 2, it'll run that. It's kind of the difference of things. And I would advise you to play around with this a little to get a little bit more of a hang of it, because it might help you in your project to be able to define these things. If it's not just, hey, compile and run this program, but maybe you want to do some things before your program runs or after. And these tasks can help you with that. So here we see a little bit more complicated example. And you find this example in your example GitHub repository. So again, we're starting with a Java application. And then we have this task and this task. And these are on this global scale here, right? They're not these, but they're defined as task and then have a name and then have brackets. And as you will see here, they get arguments. And in that case, we're saying, well, they're a Java executable task. So we actually want to run Java code on them. And what we're doing in here, we're defining a group set, because we can give our task a group set, so it gives us some kind of grouping for our task. And I'll show you that in the example in a little bit. We can give that task a description, which is of course always helpful for documentation reason. You have to say, set the class path, which is basically always this one here, unless your project structure is completely different. Then you define your main. In that case, it's threaded socket server, and down here in threaded sock client. Important, these are of course in source main Java. If they're somewhere else, you got to define that. And then here, this threaded sock server task actually expects inputs. So in that case here, we're saying, well, if the project, when I call this, has a property port, then set arguments for and use that port property. How does that look like? Well, if I call this task, I'm calling Gradle thread socket server, which is that name. And then here is my argument. P, here, uppercase, is for parameter. And then I'm using port, which is that name. And args here are the arguments which will be sent to your Java code. Same thing happens down here, right? We're saying, hey, this is the same group as this one. We're having our description here. Here we're saying, well, our program, our client actually expects some system input. So when I call this from a command line, I actually want to input something. So this is needed to allow this through Gradle. Then we define our class path, we define what our main is. And here we say, well, if we're giving arguments for host and port, then our arguments into our Java code should be host and port. How can we call this? Well, we'll say Gradle thread sock server client here, and phost, this one, is some kind of IP address or local host, right? If you're running it on your system, and then we're saying, well, the port should be 8888. How does that look in our Java code? Well, here we have the Java code to go with it to maybe help you a little bit see better what happens. So our main, which is here from our threaded socket server, it's just like this little piece of code here, right? So I didn't put the complete class in here. Here we get arguments, and here, for instance, we use that argument, which is this argument here, which in turn is this argument that I gave here when I called. So when I called here, it checks, hey, did I set the property port? Yes, I did. Well, then please send this port as argument to my Java code. Same thing happens down here, right? I am setting a host and a port. Well, it checks, do I have a host and a port? Check, I do. So send over host and port in that order. So args0 will be my host, args1 will be my port. So that's how it works. And you will need this every once in a while to set your ports or IPs or even set arguments to your program to start running. So this is important to understand. And I hope this helps you a little bit to kind of map and see what happens where. So another important thing, and I haven't talked about it before, is your Gradle wrapper. The Gradle wrapper is something very common and very good for your distribution because it can specify a specific Gradle version that you use to compile your program or that you expect for your Gradle program. It can even define a specific Java version so that your client or your colleague uses the correct Java version. And it's actually pretty good practice to use these. How you can use them? Well, you have your project set up like this, and then you basically just call Gradle wrapper. And this will create all of this. Important is you will have to add all of this to your GitHub repository if you want to distribute it through GitHub, of course. But the jar is needed to run your project, which are often ignored in general because they are often in build directories and so forth. And you will need that properties file, which basically defines your Gradle version and can also define your Java version. And then how can you run this? Well, you can use a wrapper to run. So instead of using Gradle threaded sock server and then give the arguments, you can use this, which will basically run your Gradle wrapper here, use this information here, might even download the correct Gradle version. It will not be installed. It will only be downloaded, will use to run, and then you're basically done. So this is pretty common and pretty good practice. You will see in the given example repository, we did not include the wrappers. We only included the Gradle files, because in that case, you might run on different versions, and for these examples, that is fine. So that's why they're not included. So, summary. We have a custom project structure, source main Java, that is needed where Gradle expects your source files to be. You can create a bunch of custom tasks which can expect inputs which are then given to your Java code to run. You can create wrapper to specify specific Gradle and Java versions. And of course, you can do much, much more, but I don't want to get into all of these things in detail because that will probably be too much, and we might add on some of the little things, but often the little things are included in your example code and have a comment and description on there, so that explains a little more of what's going on. I think if you understand the basic structure and the basic idea that's going on in a Gradle script, you can figure the rest out and build onto that. So thank you for watching, and I'll see you in the next video.